useful part of this. And it says that if x minus c is a factor, then p of c is 0. And it works the other way. If p of c is 0, then x minus c is a factor. In other words, x minus c is a factor means that the remainder is 0, which means p of c is going to be 0. And this is really important because it's what lets us factor polynomials and find their zeros. So let's just take a really quick look at that with this example. So we've got our polynomial, and we're dividing it by x minus 1. And let's just take a look real quick. We'll use synthetic division and see what our remainder is. So I'm going to put 1 over here because we're dividing by x minus 1, and then my coefficients, and we'll see what we get. So I'm going to drop my 1 down, multiply, add, multiply, add, multiply, and add. And so what I know right now is that this is a factor. I know that it divides evenly into my polynomial because I got 0 left over. Now in terms of the in terms of the remainder theorem, what that tells me is that p of 1 is equal to 0. And so another way of thinking of that is that 1 is an x-intercept of our function. Now we can think of that a different way too. I just divided by x minus 1, which is a factor. So I can write that as a factor. X minus 1 is a factor. And this is going to be what's left over when I divide that out. And so that's going to be x squared minus 2. There are some more zeros from here, but we're not worried about that yet. And so I know I can factor this polynomial because I divided it out and got this left over. I can factor this top polynomial as x minus 1 times x squared plus 2. That's equal to my original p of x. And there is no remainder. My remainder is 0. And so I know right away if I plug in x equals 1 to this equation, that's going to make this factor 0. So x minus 1 is an x-intercept. X minus 1 is a factor. X equals 1 is an x-intercept. And we could keep going. We could find the x-intercepts that come from this term as well. But the factor theorem just says that if we divide by a factor, or if we divide by a divisor and we get a remainder of 0, that factor gives us an x-intercept. And that's going to be the really important thing for this chapter of how we find x-intercepts of polynomial functions, is we're looking for those factors. And we're going to be using synthetic division to show that they are indeed factors.